Hi, my name is Faisal Kasim, and this is my Physics Lab 6 assignment. Right off the bat, I'm just going to mention the fundamental physics concepts we use in this lab: Faraday's law of induction, Lenz's law, magnetic forces between currents in a magnet, and materials used, foil paper and a bar magnet. So for this lab, what we did was we passed a bar magnet through an aluminum foil paper wrap and measured the time it went in and time it came back out to see how long it spent inside the bar magnet. And for that, I didn't put the value there, but I got 0.6 seconds. Yeah. And then we were tasked with creating a computational model, which is a code, to then test to see if that time is accurate and what it means. So from this code, you can see we measured the length of the tube, the width of the foil, the inner radius of the tube, and the outer radius. Yeah, so that's on the next one. On the next page, you can see we also measured the mass and the magnitude of the magnetic dipole moment from lab 3. Now, I feel like a main reason why my answers do not align and my graph does not look the same is because the magnetic dipole moment is wrong. And you'll see that at the end of this video. Or rather on the next page with our graph and speed. And here's what I refer to. Now in theory, if this code was done the right way, what we would be seeing on the graph is a dip. We would be seeing a steep initial slope, and then a slope that decreases inside the tube, and then a flat region where it reaches terminal velocity, and then the moment it exits the tube. But here we're seeing just a straight line, and the time in tube was 0.225 seconds, which is not accurate with the real life values. But now on to the questions. Which color is clockwise and which is counterclockwise, and how do we know? So this is seen from the code. If the ring current is greater than 0, the color will be red. Else, it'll be blue. Because red is a positive current, and it is the one that is clockwise viewed from above, and blue is negative current, counterclockwise viewed from above. Next question. What happens to the dynamics when you flip the magnet around? Well, simple answer, the colors would reverse, but the magnet still shows dynamics remain quantitatively the same. This is because by Lenz's law and the force expression on a dipole, the magnetic damping still opposes the magnet's motion. So flipping the magnetic dipole flips the sign of the flux change, and thus the ring currents, and also flips the sign of the dipole. So the product determines the force remains such that it opposes the motion, meaning it will be the exact same, just in the opposite. So colors reversed. And how does the real magnet's time in tube compare to the simulation? How to improve accuracy? Well, there are a few ways we can do this. The imperfections are mostly from real aluminum foil has imperfections. Simulation uses an ideal dipole moment and perfect rings, which is not perfectly matched to real setup because I can't calculate the real magnetic dipole moment. And the simulation and ways to improve the accuracy is using smaller ring spacing for finer resolution, using the measured magnetic dipole moment of the magnet, and including more realistic aluminum properties. And the last question was pretty much answered, velocity versus time plot. What it was in theory meant to show was how magnetic damping builds up until it balances gravity, demonstrating Lenz's law in action. Thank you.